Right, so I think we've figured out the issue with Twitch. It was if we're multi-streaming, we literally can't go above 6 megabytes in quality. So I'm not sure how this is going to affect quality. Let me just get rid of the test message now. So let's just see what this quality looks like, because this is much more reduced. We were streaming at 20 meg, and now we're streaming at 6. So let's just get something a bit detailed on. Do I have the overhead camera yet? Yeah, I do. So let's try and see what quality we're dealing with. Let's get some stuff in. It's got quite a bit on. Let me take a look at that. Oh yeah, that's not the best quality. So that's really limiting the bitrate is really limiting that quality. I mean, it's not terrible, but the Twitch stream versus my actual visual monitor, it's noticeably less. Not terrible. So I guess that's well, it's the only option we have if we want to stream on Twitch. I think you can't go above that. So let me just quickly check out the YouTube. The bitrate is really limited. Turn off the audio so we don't loop. Do the same test. Let's just see. Yeah, I mean, it's not terrible. It's manageable. So at least we've got a stream now that is going out to Twitch and YouTube. And let me just check Facebook. And I suppose now I'm on here, I might as well just do another little bit of work on this Mac, I guess. Wasn't planning on it, but I might as well just do a quick half hour or hour's work. If you want to stream on Twitch. There we go, just checking Facebook. So Facebook's actually gone horizontal. I thought I was streaming vertical on Facebook, but maybe not. Those on Facebook as well, what do you prefer actually seeing? Do you want horizontal or would you prefer vertical? Because I think I can only select one to stream, so I don't know which one to use. But that's all of them. Let's just check TikTok as a last resort. Oh, they're all streaming horizontal. Is everybody's feed horizontal? I might have messed up on the, like, I can't remember when I've gone live on and off a few times now and not really paid attention, but I thought I'd selected vertical on TikTok and on Facebook, but they both look horizontal, but at least they're working. That's the main thing. Everything seems to be working now. So we do appear to be streaming to all the platforms now, and I've got this little handy remote for turning this camera a bit easier, and then setting up some pre-made positions, so I can, like, say, zoom out, get a nice wide angle here, and then say just hold the custom position 1. Now I can say move, zoom in. Let's get another nice angle for working on. So that's probably a good angle there. Hold position 2. And now what I can do is just nice and easily tap this. I don't quite like the location. The zoom's smooth, the location's a bit snappy, but that sets us up to wide. Tap again, zooms in. So, oh yeah, I fixed the resolution as well, 1080p now. It's just, I must have just not selected vertical with me toggling on and off all the settings and trying to get Twitch to work. So I'm sure it'll work in vertical next time. Right, so like I said, I wasn't really planning to do a live, but we might as well do one now. For those of you that missed this morning, because it was quite early on, let's just zoom that out. We have now 2 working Mac out of the 3. So we have the original, well, I say the original, the one I brought the other day and fixed up first. This one still fully works. This one we fixed this morning. Turned out to just be, of all things, right under the SCSI. There was a bridge under here. Let's just go to the overhead. And where were we? SCSI chip, somewhere around here. So on this, let's go in closer. These 3 vias here, these top 2 were bridged. And I believe that comes from, well, it definitely did. It'll have come from when I was swapping this chip between systems. These 2 vias here, when I'm tinning the pads on, say like on here when they're empty. So when I'm applying fresh solder to these pads, what's happened is it's had a bit too much and then gone through those 2 via holes onto the other side and bridged them. So that's that one fixed as well. And that's those 2 working. So what we want to do now is, this is finally the customers, this was the ultimate goal anyway, was to get this thing working again. But the last I did on this, we have absolutely nothing. So we don't get any diagnostics, we don't get any audio, we get nothing at all. So let's just confirm, as I always like to do, that at the minute everything fully works. So let's get this bootable SCSI device here. Let's get the power. And that goes in that way. I think the most awkward thing about these is not having extension leads to hand. So you don't need to rest it up against the monitor. So with that, we should, I think, yeah, we haven't got enough RAM, but it should boot up and tell us we don't have enough RAM. So that's what we should get. So there you go. So we get the happy Mac. Welcome to Mac, and then we'll just let this boot a minute. So we know monitor's still working. The reason I do this check as well is because, I just noticed as well. Let me just do some live adjustment here. Actually, it doesn't matter. We're not streaming vertical, but my vertical setup's all messed up because I changed cameras and never bothered setting it up. Yeah, so we get this issue. The reason I do this test is literally this sitting overnight. The hard drive in the back has died. So I always like to, before I start working, just double check everything is working that, we want to. So we know this SCSI device is working. We know the power connector's working because this also broke. And we know the boards that were working are still working. So with that, we need to try and get this thing working. Now I'm going to just chuck back on the VIAs and the is it ADB on there. We don't need the SCSI chip, but again, I guess it won't harm. Let me just mute my phones as well. I forgot to mute all them. Like I said, I wasn't planning on doing a live a minute ago. So yeah, let me just put some chips back on. We'll start with that. So we're going to put on the VIAs first. I'll just get some hot air on the go. And I like to do these under the scope, just so I can align them. Otherwise, they can be a bit tricky to align. So these are the ones that were pre-tested and swapped between to make sure they work. So I'll warm these up. What I'll do is, I really just want to do these under the scope a minute. Just because, like I say, I want to get these on. There we go. And then we definitely want to, because of what happened on the last board, I said we want to visually inspect all these, in case any of that solder blob through the vias has happened on this board, because this was fully working until I flowed some solder near the SCSI chip, similar to the other board, so that's what's making me think. I'm hoping we'll just find a blob of solder, basically. It'll be a nice easy fix, considering these have actually been quite a complicated fix. I've even written software just to try and diagnose these. You can get to see, let me just nudge it in position. That goes over there. Ooh, that tweezers are hot. Now I've got it in position. There you go. What the main thing was, I suppose I can align it on there. Because I push these chips down when soldering, I want to make sure these were perfectly aligned. That looks a little bit blurry as well. Are we slightly out of focus? Yes, we are. There we go. So yeah, see how the pins are really nicely aligned all round? And then what I'll do is when it's warmed up, I push down firm. So I guess I could just also hover my head over like that when I'm just about to press down. So I can literally use the live stream as a microscope because it's that close. Right, that's molten enough, so now I'll push down firm and check that everything looks still aligned. And then if it does, keep the pressure on firm. This is the key to these PLCC chips is keep the pressure, like literally push down fairly hard because they're not the best package to install. But obviously you've seen me do I don't know how many of these now in a row, and they're always good if you follow this technique. Get them nice and hot so all the solder's molten, make sure they're lined up good, and then just push down really firm. Hot air temps, everybody asks that all the time, but in one way I don't say it because it's different per equipment and per board, but obviously it's useful information. In general I'd run 470 degrees C and 80% airspeed. I think I'm still running that at the minute. No, I'm running 490 and 90 at the minute, and that just helps me work a little bit faster. Now let's just inspect these. So zoom that way, and it's a little bit, I can't quite get the focus zoomed out enough because the board's too high to focus there, but you can see they're nicely soldered. Nicely soldered. Yep, they look all solid and flown well. And people struggle with these, rightly so. They are probably one of the worst packages I find. And then that looks like, you know, these, where are we? These pins maybe don't look soldered, but under the scope, I'll quickly check they usually are. It's just the angle. It makes it look like there's a bubble on top. Zoom right in. Yeah, they're rock solid, so they're all soldered good. Same again for the others. Let's just zoom out a little bit. Go on to there. And now we put on this other one. So this is the one I just rested above. Oh, that's actually got partially soldered from the last one. Just it literally sitting in place. There must have been enough heat to start melting there. So we're going to have to warm him back up and move him into position. Let me just get my big head over the top now, just to align this. That looks good. Push down. And I think the main issue people have with, to be honest, most reflow soldering that I've seen when I kind of watch other people soldering, or hot airing rather, I tend to find a lot of people are just scared of the heat. They just don't heat things up enough. Like if you're not seeing the solder bubbling and the flux bubbling away, you've got nowhere near hot enough. A lot of people will go until you kind of, what happens is first is the chip warms up and melts solder, so does the board, and then they bond together, the heat rapidly dissipates throughout the board, and everything cools back down, and you haven't finished reflowing yet. So you'll get like normally the chip will nudge, or something will stick, and you see a bit of movement. Once that happens, everything cools back down because it's bonded and they share the heat. People tend to stop there and think they've done. You need to keep pushing past that. Warm it up again for at least another probably 10 seconds in most cases, so everything starts bubbling, and that's when you really get the reflow that you need. I think that's the key point that I see people fail at, in a sense, like where they go wrong. But as you've seen from these, at the minute all I seem to be doing is hot airing chips, whether it's Game Gear PCBs or Macs. That's majority of what I'm doing at the minute, and it never really goes wrong once you've done enough of them. You just get that used to it. That, well, like now I've not even used a scope on this one, and I'll still verify it's good with the scope, but a quick look at it tells us it probably is. Yep, so again, that looks nice and smooth, and that's what you're after, those clean, so like it just looks smooth and clean in one join. There's no like, have we got anything on here that's not well soldered? Not really. But you're basically looking for what you see there. It just looks clinically clean and the joints just flow. That's ideally what you're after. And that's when you've got it warm enough that everything's just allowed surface tension to do its job. Can we get into that one? Oh, we've got spam on Twitch now as well. I've got like, 60 followers on Twitch, and I'm still getting spam on there. Yeah, that's I think that's all good. I'll do one last visual under the actual scope so I can see with my own eyes with depth perception. That's the only thing you're missing on a screen, is it's hard to solder using a screen if you're not used to that, because there's zero depth perception. Whereas a microscope, you've got actual stereoscopic vision. It really does help. Yeah, all good. Now let's do the last one, which is the ADB port. Again, it's not needed. We're just chucking all these chips on. Get that focused. I wish this lens had autofocus above. That'd be really useful. There we go. And the little chips are no easier or no more difficult than the large chips. Principle's exactly the same. In fact, we need a little bit of solder on that bottom corner first. Zoom in a little bit with this being small. There we go. Zoom in digitally so we get even closer. Yeah, look at that. Super close. In fact, super close, but a little bit blurry. Is that because we're slightly out of focus, or is that just the digital zoom being? Oh yeah, there we go. Look at that, crisp. Right, let's get this chip on. Where have I put him? There. The only thing with the little chips is I'm not that fussed normally about the alignment as much as I am with big chips. I like to kind of align the PLCC big chips because you get bridges normally under them, whereas the little chips are not as bad for making a bridge, but are still, unlike the Game Gear chips where alignment really doesn't matter, the PLCCs I like to try and align at least somewhat. It just helps in the long run. Let's look at this. And the other reason is, yeah, all these chips are known working since the last time, but we've had that many chip swaps. But these are all, the engravings are from my original known working, so you see the actual engravings I've done there, K11, that one is probably K11 as well, but either way the VIAs are interchangeable. And this one is 11 again, because it's obviously UL11. That one I think I have slanted by the looks of it. Well, I've been talking and not looking. Yeah, a little bit slanted. Let me just align. He'll be fine, but I'm going to align him under the scope just while he's still warm. Just get him nicely aligned. And I don't think either, well, I'm pretty sure these chips aren't actually needed for boot, like at least boot up to something. We don't get anything at all, so we get no SAD/MAC tone, we get absolutely nothing. And none of these chips are technically needed to at least get that. So I'm not too fussed about these at the minute, but they were all tested the last time we had a working Mac, so pretty confident that these are fine. There we go. The SCSI chip I'm definitely just not going to bother with at the minute. So we have the SCSI chip down here. We know what happens. We've done that with the last two. The system will just simply boot and get the cursor, but no flashing question marks, because SCSI just hangs. So we know if we get the cursor, we're a lot further forward than we were, so we're not going to bother just putting the SCSI on for now. Sound chip, however, we will transfer that UE10 over as well off one of the working boards, because we have booted without that, and I'll do that again anyway. I will confirm that you get full boot without the sound chip, because if you remove the sound chips, they can't hold the system in reset. But saying that, you can't then use the reset button easily, so we'll just transfer that over, keep it simple. Q3 is, I doubt that's going to be the only issue. If I show you over here, just notice this. I can't remember, I think this came off in the last video. I think Q3's just come off while we're hot airing that. I do not have a lab coat. I've got a outdoor barbecue leather jacket. That's about as close as a lab coat as you get. So last step before we can test is we'll get this UE10 on. So I'm just going to pick this board, pick any board, we're going to take it off this one and transfer it over. If anybody has one of these chips, I definitely need one, because we had to fix another Mac. In fact, the Mac we're trying to fix below, this is the chip that was originally bad. So that's literally why I'm one short. So we've nicked him. Now let's put him on here. Oh yeah, you're not wrong with the caps. I've had a few pop in my face, and I was literally looking at that cap as I was doing that. I was thinking we're overdue a cap explosion for sure. This chip's been pushed down that many times, we have a divot in the middle of this chip. I do find this reloaded board as well. This board definitely bows more than the originals. This has got whatever profile or layers this has got. This is definitely prone to warping in the centre when you're hot airing. I'll try and move this camera as well. I think the default position's a bit better being sort of there, I'd say. Save that in. And let's also zoom in. Thanks, I'm glad you're liking all the products. This is something I probably want to show off on stream at some point, as obviously I do a lot of repairs, but all the hardware I make, most of the stuff I stream and record ends up being repairs. I just find it more interesting. I don't tend to talk too much about my own products. I tend to enjoy the mysteries more than the known working products. But I should definitely show off stuff I make. Just clean up this flux a bit. It's a bit sticky over here. You probably know as much as me about Macs at the minute. I don't know much about them at all. I've fixed two of them, but that's about the only thing I've done with them so far. I'll go through the overview. Let me just clean this desk a little bit. We're getting a little bit messy. Just clean the back of this board as well, actually. Just clean the desk and now we'll get covered in sponge. This is the reason melamine sponge works so well as well, because it shreds up when you're wiping over the connectors, but while you're doing that, you're managing to clean everything in between all the connections, whereas if you use a normal rag, this just catches and rips. So this is impossible to clean that. For the US, we actually have a US site now, retro6.us, and it's a guy who runs another TikTok called Crossface Gaming. If you look him up, he's our official US guy now, if you will. So he works with us closely and independently runs the Retro6 US, but with our backing in essence. So we fully warranty anything he ships out, and just allows the US people to get a more direct and local product for Retro6. So you can still buy from us, but the only shipping we have now to the US, thanks to Trump, is DHL. So our local post literally doesn't ship to the US anymore, other than prepaying duties, which is just not really something we're interested in doing. It takes too much time, too much hassle, too much software. So if you're going to order a largish order, you can just pay DHL and we'll ship. Otherwise, just go on retro6.us and they should have literally everything of our products. If they don't, just let us know, and obviously we can work with them to make sure they have stock. Zoom back out a minute. Right, where are we up to? We have everything soldered on. Let me just check that UE10 under the scope as well. Yep, that's all good. So where we're up to now is we have this back to where we were. Let's rob the RAM off here that we know works. Oh, these, I swear I'm going to break all me. I haven't even got any fingernails now, I've cut them, but these connectors are crazy firm for destroying fingernails. So this is 1 meg of RAM, but enough to boot. And the other thing we can test is, I'll just bin one of the Macs. I've got an ace habit of resting things on top of the bin. Let's just get the audio. Let's see if we get Deathmatch Chime, which we weren't getting before, and so I don't think we'll get now, but we might as well try. No, so see, absolutely nothing. So without RAM, and we don't even need RAM to be honest at this point, because that's kind of the point, we get nothing. So this is no sound, which is normally these chips, and unless these happen to be the issue, which are brand new ROMs. So basically, for those that are asking, these white slots here are the RAM. This down here is the ROM. So this is like your operating system, your base kernel, if you will. This is here. They normally stick up like that. So it's normally an upright. This is a remade board. So we have these sockets. And from what I've learned, this is all info, by the way, I've learned repairing 3 of them. So don't take my word, I'm far from an expert. We have the CPU, the 68K here. We have a glue chip, which basically links a lot of stuff around the system together. Floating point unit for math calculations. A bunch of these are all buffers and translators between the 68K, the glue chip, and the RAM to make them talk to each other, and the ROM. All this lot is pretty much video circuitry. So these two are the video RAM. These chips have a mixed function, but they're basically all PLAs, programmable logic something or other. And these just act, you send a pin in to one thing and it makes other pins toggle. So it's just like almost like a glue chip. It's linking things custom on this board together. But most of them are involved in outputting to the screen. Same with up here. I think these translators are mostly related to the video. Then we have, it's a bit zoomy in. Let's zoom out the top down a bit. There we go. Move him out of the way. Okay, let's power him down so it doesn't work. After that, we've got the swim chip that controls the floppy drive, the 2 VIAs. I forget already. We looked it up in the schematic. We just looked where they were going. I think it was serial ports, maybe. Can't quite remember. The ADB is for the keyboard and mouse. The SCSI here is for the hard drive, so the SCSI connector. These and all these, so all this outputs diagnostics to the serial, as well as whatever the serial port was used for. These are sound, and then fuses and generic components. We have a clock here, which the clock's missing, but we confirmed it doesn't stop the system booting. We did that on a working one. So that's pretty much all the system. You kind of get to know them fairly quick when you're working on new things, but like I say, I knew nothing about these a few weeks ago, and now I can get my way around them fairly easily. So where do we go with this one then? This is the question. We have, well, what we're looking for is the death chime, which should happen. And I wrote on the wiki, let's just review my own notes, because I've even forgot what I wrote when I was originally diagnosing this. Before I'd even got one working, I made quite a lot of notes. Minimal boots, let's move him over. Jump to the PC. So I wrote this from knowledge that I built up working on one. And the whole point of this was to try and get, I didn't even have a power supply at this point. I had no power supply, no monitor. I jerry-rigged together a clean RGB and a HDMI adapter to actually see something on screen. So my goal was sort of what was the first thing that should happen. And we realized it was basically the SADMAC tone, which should come out of the audio. And for that, you can leave out all the RAM. You need the ROM, the 68K. You need the 5-volt rail only. And this is me basically powering up from nothing, so directly from bench. Mapped out all these, so we know we need ground and 5 volts only. I then pulled out the video H-Sync and V-Sync and made a little adapter. A quick check on system clocks. And this was one of the key things coming out of reset. I did quite a bit of work on finding out what resets the system. So the VIAs can keep the system in reset. The ADB, which is the little chip that we just put on for the keyboard and mouse, that can keep it out. The swim chip for the floppy, that can. The SCSI can. And the sound chips can. So these are all things that affect the reset. So the first thing we want to do is check if we're out of reset, and if not, we should probably loop back and check these. And then obviously, if you're not out of reset, the only reason this works, this is basically the stuff that's in RAM. So this is just the video RAM dumping out its own circuit with nothing happening. So that doesn't mean anything's running, and this is a different RAM pattern. This could mean the entire system's in reset and nothing's running. It's just the video circuitry is running. So that's all we gather from that. So let's just start with the reset line and try and figure that out first. Yeah, I'm glad you're liking the wiki as well. It's I've put literally years of work into that over time, mostly because I forget what I've done the next day. So hence why I look back at the wiki. But it's obviously become quite popular now. I get a lot of people that know we have a wiki and don't even know I sell stuff. So they'll go like, oh yeah, I'm really after buying, say a Mega Drive, or do you know anyone that fixes stuff? And I'm like, that's literally what we do. The wiki is the side business, but people know me now more for giving away the knowledge than selling stuff, which is not necessarily a smart thing, but at least people are using the wiki, and it's useful for people, keeping all the old consoles alive, and more so the old computers now. So let's get this going. Let's pull up the Picoscope. Let's overlay the, what shall we do? We'll go over the top, I think. Top-down view and get this into sight. Power up. And of course my scope is playing up. Let me just reset it. Make sure I don't unplug the cameras. There we go. Right, so set the probe up for kind of a universal view there. Right, so now get this a bit across. We don't need to see screen. What we need to see, is the reset line. So pin 1, 2, 3, 4, 5. And we're high. So the reset line is working, but let's also look for a toggle. There you go. So that's the reset toggle. So if I do that and go back to the waveform, pull up the PC, you can see this is us pressing the button here is low. So it basically just shorts the rail low when you press the button. Comes out of reset. This drop then, I presume, is either the 68K or the ROM or the glue chip, putting everything in reset while it initializes and then coming out and staying out of reset. So that's a good sign in some way. Something's working, basically. And now, if we have the reset and we're out of reset, where does that leave us? I suppose next we want to check out the data bus to see, well, actually, considering, no, we don't have the SCSI on. We don't have audio. See, I haven't really done much diagnostics in between coming out of reset and not getting a chime. So this is kind of a, all I usually know from this is we're typically dealing with the ROM not working. So the ROM is the thing that will kick in first, communicate and try and do, say, a RAM test and other things, and if it fails, it outputs audio. We could be dealing with, yeah, there's a point. We could be dealing with the sound not working because this had an issue with sound and this sound chip was going to 100 degrees, which it is not anymore. But we might be having a death chime and not hearing it. So we might have to probe the sound chip here to figure that out. We might have to see, are we getting digital signals to this that mimic the death chime? That would be useful. We can also probe the data pins on here. So I'm going to pull up the schematic to find where some data pins are. And I just want to see what's happening on the data rails, see if something's activating and running. And we can always compare this to a working, like one of the working Macs we've got with all the RAM out to see if we're getting similar behavior. So let me just look at the ROM sim. So the pin 4 onwards is address, and pin 14 to pretty much the end, they're all address and data pin. So pretty much, to be honest, all of the ROM sim is data and address. So what we can do is probe. So the first couple in, so around here is going to be address pins. So we'll put that over. And where is, have I closed down the Picoscope? No, I haven't. There we go. So we start this up again. This is now an address pin. Let's reset. Nothing. So this is the strange thing. Ah, there you go. Got something on that one. And obviously, it's running for a short time and failing. Very short time. That's like 2 pulses. Let's go a bit over to where data is. That's a little bit more. Let's go down to 10 microseconds. Maybe 20. Drag this back. Right, so that's what we're talking there. So I guess one of the first things we need to do is see if that's normal. So is this amount of data normal that we're seeing here? So we have, this is just a random data pin, but the timing will be the important thing. If we pull off the timing when it starts to when it kind of just decides it's had enough, there's 47 microseconds. So after 47 microseconds, this thing's had enough and it's just not pulling reset low, which we can just double check it doesn't. But it's also not doing anything as far as we know. So let's just go 1, 2, 3, 4, 5. And obviously we'd really need to align this with the data pins to know for sure. But I'm pretty sure that pulse will be very similar. 33, yeah. So the chances are if we go 33, go before that, 38. So that's the amount of time. I bet you any money it's roughly around there. So that's the time that the other signal was active for, and this is the reset pulse and glitch. So it's very close and very similar, that we're likely dealing with the fact that it finishes whatever it's trying to do at that point and gives up. So I think what I'll do first is and this is why we need 2 working Macs. That's why I said I kind of wanted 2 working Macs. We've had to rob the sound chip off one, so now we can't really use that one to do identical tests. But now we have another one. Will be in this one. I want to now get this one in the same state as this, which is basically short of the SCSI being on, which shouldn't matter because if it fails a RAM test, it won't even get to check in the SCSI. We should just be able to remove this RAM, and now these are in a similar state. And if we grip on the ground to keep it out of the way, put the audio in, and this is what I'm expecting to happen on the customers, which is where we get that it doesn't. So you hear that chime? That's the SADMAC chime. That's what we're after. And we don't get that. Now, if I probe on these data pins, let's see what happens. Well, firstly, let's see what happens with the reset line. So 1, 2, 3, 4, 5. And let's put that over there and reset. So it's good that the reset's identical. So that's kind of saying that we're coming out of reset. Let's just check the length if it's the same. So it was like, what, 38, I think? Yeah, absolutely identical. So the reset is happening just the same. Let's take out the ROM. So obviously we get no chime, but let's inspect what happens to reset. So we're on the reset line. We'll power up. And let's start that again. So no death chime, no pulse on reset. So that's telling me, which is good, that I think the ROM is booting, because without the ROM, we don't get that pulsed line. So I wonder if we are coming out of reset and it's making the jingle, but we can't hear it because there's something wrong with the sound circuit. So what do we do with that info? Let's check the data pins first. Let's see how they're reacting. Go roughly somewhere down here, and you can see there's the difference. So the data and address pins are constantly looping. Now this is what we're not getting. So address pins, you've seen our address pins, they start and stop immediately. So it's almost like we're dealing with, which could be, and again, we've checked all these things, but this is where we've just got to ignore that for now. It would typically relate to something down here, because what happens is the ROM's here and the 68K, just because this is how 68K systems typically work, this thing is what's processing the data. So the ROM stores the computer code, if you will, that the 68K needs to execute. So these two have got to talk in order to load, and I'm guessing the glue chip is what's controlling the reset line, not necessarily the ROM. But if the ROM's not there, the reset line does nothing. So it's in some way telling us something's partially working. But all these transistors, I keep calling them transistors, all these transceivers here and buffers are related to, you know, the main communication between these and these. So I'd say this is the area we should look around. But there's also a chance that just anywhere on the data or address bus there's a short. And given the fact that the last one that we fixed had a short caused by me, I really want to focus on just a little bit of looking around this board first to looking for any kind of short that's happened. And given that this was basically a working board, I've said it probably 50 times now, but this was a working board until I reflowed some solder down here. So that's all that happened to get this board not work. We thought the SCSI was a problem. I put my soldering iron down here, reflowed. I'm pretty confident I did nothing, I didn't short anything, but since then, it just never worked at all. It stopped booting altogether. So I really want to probably visually inspect all of these pins. And we could do with all of these being nicely in focus. So is that there? That's a good focus, and maybe zooming in so you guys can try and spot anything. Will go nice and slow on this, and you guys tell me if you see any kind of shorts. So we're looking at, you know, all the pins, if any of them are bridging together, or if anything looks odd, like we're missing a component, or a component slanted. Because I'm kind of hoping, and I'm kind of thinking that also, that's the most likely thing. So things like these little dots here, 2 little dots, that's what happened on the last one, 2 little vias joined together. So just keep an eye out for anything that looks suspect, especially in this top area that we're working on, because this is where it was. I'm glad you're joining in and enjoying the lives as well. I've started doing this was an unintentional one. I was testing the equipment and it worked, so I just stayed on for a quick live. And now we're just basically trying to find missing components or shorts that obviously I could quite easily overlook. And then anywhere there's like a bit of fluff as well. Where's the camera at? Ooh, there. Just get rid of like fluff so it's definitely clear, and little solder balls. But anything at all out of the ordinary, definitely shout up. And like even like this, you see, so this is something I'd be questioning. Is this normal? I can see with my eyes it is, but anything at all like that, anything that looks not perfect. VTech, I might have. I've worked on a lot of stuff, but nothing's ringing a bell. I'm not necessarily saying I have, but I believe I've worked on 1 or 2, not many. And this is going to be quite a bit of time to check, but I do think it's worthwhile given the last one turned out to be that, and it kind of makes sense that I was working on, you know, basically the last thing before this worked was that I touched it with a soldering iron, so. Looks like a little scratch there. Let me check that under the scope. Just on there. I mean, I don't think it's gone through. This board's a remake. This one we're working on at the minute. This is the one of the 3 that's actually a remade board. Let's expose the copper, but I'm 99% sure those joints are fine. Let's double check. So we have a via going all the way over to there. So that should be that one, which makes its way to there. So that's fine. The other one is that. Yeah, so that's nothing. So it's taken off some of it, but that's not the problem. So that's something that's happened at some point, just a slight scrape, but it's not cut through the trace. Let me just have a quick glance at that. And where are we there? I've lost it already. Saw it under the scope and then lost it after there. That was miles out of the way. Yeah, that's nothing, that's fine. Where were we now? This is going to be fun, trying to find out where we were at. So that was the scrape that we checked. There's the other scrape we checked. Those two pins are joined anyway, so it's not them. This is all the mains power. So this is a little bit scuffy because we've obviously soldered power on there a few times, but that's all fine. Nothing yet, so we're moving away from the part where at least I was soldering originally. C49. How long ago was that? C49. C48. I can see everything except that. L16, L10, L14, oh, down here. C49. Still not there. Can't see anything on C49. What are you seeing on C49? We've got a via there. We've got a ground via there. Yeah, I'm not seeing anything visually here. We've got a blob of solder there. That cap's all fine. That via's fine. That pad, I don't think has anything on. Let me just look at that via there, make sure it's not shorting. No, that's fine. No, there's nothing under the scope and nothing I can see there, but I am not sure what part you're seeing, but I've looked all in this area. There's nothing there that stands out to me as a problem. There's a bit of fluff in a few places. Just clean this area. They're all good. You realise how much fluff you've left on the board when you inspect every area of it. So actually, that's probably the last place we were at. Just back to where we were at the edge. And I have done a visual inspection of this before, but obviously you can miss things. So here's a little bit of a nick on there. Let me just check that out under the scope. Yeah, that's fine. So that's just taken, similar thing, it's just taken the silk screen off. L12. Yeah, he doesn't look the best. I don't think he's an issue, but I'll just move him back into place. Still doesn't look the best, but he's. I think that's just more the size. Yeah, it's like the component pad almost isn't right for the type of component. And just check him out under the scope, make sure he's not missing pads or anything. Let me just also, in fact, I'll just take him off and check that where it's going isn't short into anything either. So that's where it goes. Let's just clean that area up. So it's going to a little via there and that pad there. But the size of the component, it's not the right size for the footprint really. It's quite a tight footprint. Like the footprint's technically valid, but this is more of a footprint you'd use with mass assembly, not hand soldering, that this board's made for. So normally if you're making a board designed for a mass assembly, then you can use tight footprints, but when you're designing it for people to hand solder, you tend to make the footprints wider. There's literally like 2 profiles for what type of install and build it's going to be. So I'd say this footprint's really a build for machine assembly. So yeah, that goes on, but like you see, the pad just doesn't look the best. It's like it doesn't take the solder, but it's definitely on. So I'll just blob a bit of solder on that side. It's now centered, but that's as good visually as that's getting. But the main thing is it's on sound and there's no issue there. Just do continuity. Go to that via and to there. So yeah, that's sound. Right, so that looks a little bit, no, just a hair. What I tend to find sometimes as well, if you just spray the board with IPA, it makes all the reflections and the light kind of smooth out, so it's a little bit easier to see if things are good. See, we've got a couple of nicks on the silk screen there again, but they're fine. I checked them when I checked the other one up here somewhere. No shorts between these. To be honest, none of these really matter unless they were shorting out data pins, because obviously this is the RAM sockets where nothing's installed. But if the pins were shorting out, then it would still affect the data bus. That one is slight. I think we looked at this before as well. That's slightly bridging over, but it's meant to be a ground pad. It's just that the silk screen's exposed, so that's normal. Bit of floating solder, that won't be helping. See, it could be something like that where we've got some solder ball from a bit of previous work that's floating around and it's just made contact. That would also potentially make sense as to why this board kind of went from fully working to not working at all. So I'm almost expecting something like that, where we have, you know, a hairline solder blob on something. I think there's quite a lot of these little flecks of solder. Again there, see this solder here? And this board did have some pretty bad soldering when it first come in. One of the main jobs I did was to reflow an absolute ton of solder on this board. It had a lot of lead-free solder and bad joints, so these little flecks of solder might be remnants of that. Right, so we were over here. It's time to scan over again. There's a lot of ears in here to look at. And you can see that the solder starting to come through the vias there. That's like the kind of thing I mentioned that happened on the last one. Once enough come through, it ended up making a short to another pad. That's why you should really tent the vias. Now these are the ROM chips we have. That needs to be bridged when you're using these sockets, and we know this worked because since installing these ROM chips I've had it working. So we know, like, you know, this solder blob and this solder blob are correct because, like I say, we've had it working since these have been installed. So it's not necessarily or directly related to the ROM chips. Whether they've since failed or something else has gone wrong, we can't remove that from the equation, but at least we know they're installed right and they're in the right way and these blobs are correct, for example. See, no issue there. So I think that's all the board we've done, all down here, all to there. So that's all the bottom side, and I've not spotted anything at all. So I guess there's not that much on the other side, so let's just have a quick look around the top side now. Let's try to get this a bit more into focus. These are all in socket and haven't moved again, so again I can't imagine them being the issue. A bit of solder mask removed there, but the trace is fine. This isn't critical for boot anyway. These, however, are. This is the area I'm on about that's fairly critical to boot, so just try and get these as clean as possible. And these were all working, so hence the green blob. So again, the chances of component failure are less. It's not necessarily a guarantee, but the chances of those chips not working is much less than it being something else like a bad solder joint. I'll try and rotate this around. That pin doesn't look the best, does it? That third one down. Let me just look under the scope. It might just be a reflection thing. No, it's well soldered. It's actually covered in solder. It's just a camera visual, so that leg's fine. That leg again, you can see the tips of the legs. Let me just check. I can see the legs. Let me try pushing them. Yeah, they're well soldered. And I think we also checked these 3 packs as well. So these 3 resistor packs, the yellow are resistors, just straight through resistors. We measured all those, they're fine, and I believe these go to the RAM, so it won't be that because they're not even installed. This is the, I believe, is this video ROM or something? Yeah, it says video ROM there. I'm not sure, I don't think that stops boot. I could be wrong, but I'm pretty sure that's non-vital. It just means you won't get video out. These are the chips we've just put on, so we've already inspected them fully under the scope. We know these have no issues, no shorts. So we're just looking around the vias really in this area more than anything, just to see if there's any shorts, between these vias. Yeah, thanks. It's literally the normal camera above, just zoomed in and digitally zoomed in after, so it pretty much works like a microscope. It's ideal. Things look so dirty when you get it under a camera, but the boards practically look spotless to the eye. Well, like I said, probably what I might do tonight anyway is put this in the dishwasher just to give it a full clean. It's better than an ultrasonic cleaner, really. And then you never know, there might be some hairline solder blobs that get removed and it works. So I'm not seeing anything untoward anywhere yet. Those traces, not that they matter because we're not having that chip on yet. Even if they were broke, then it wouldn't be a problem. Yeah, the best way, literally clean the board is chuck it in the dishwasher, by far. So it gets up to like 70, 80 degrees, it jets water at it, rinses it. Once you take it out of the dishwasher, just spray it with IPA. That gets rid of the contaminants, and it's literally, it's as good as an ultrasonic cleaner. Hey, welcome to the stream. We're just looking for shorts, basically. We're looking for things accidentally joined together, like these vias. But so far we're having no luck. It doesn't look like I can see any issues. Oh no, dishwashers are definite. I'm sure it's not only me that does it. I think some people just won't admit doing it, but works amazing. Like you can see the state of this board in a minute. Like here, for example, look at all the flux, all the blobs. I'll chuck this in the dishwasher tonight, and everywhere you see this, it's going to come out flawless. There won't be anything. There'll be all these patchy bits, all these blobs, absolutely everything. I'll guarantee this will come out, and you'll look under the scope, and everything, all this imperfection, all the hairs, all the blobs, it's just going to come out looking brand new. These, now, don't want to go down another rabbit hole yet, but where are we? This chip and these two and all this lot, I'm sure are related to Diagnostics, but I'm wondering whether if they were faulty, it actually won't. No, definitely not joking about a dishwasher. I'm 100% putting this in there tonight, and you'll see the difference. All you got to do is make sure you rinse the board with IPA once it's done. Yeah, the missus doesn't like it when I put the dishwasher on and it's full of PCBs instead of plates. Yeah, so I'm not seeing anything, unfortunately. Anything at all that looks out of place there. So let me just use my eyes instead of looking at that screen for a minute. And let's just do a few basic checks as well, like fuses. It's a diode, fuse, caps are all good. I'll tell you what, considering we've just probed around as well and cleaned off a few blobs, let's just double check this is still completely broken. Yeah, you literally run the dishwasher like you're doing plates. So put the washing pod in, everything in, run it completely normal. It will literally wash it with soap. It will get rid of all the flux. And then, like I say, once you've taken it out, just make sure you clean it with IPA, because that'll get rid of any remaining water contaminants that are in the water itself. Yeah, so nothing at all. Out of reset, clock happening. Let's push on a few components and try resetting. And this might find things like broken traces or potential bad solder joints. Another trick we can do as well is, let's take out all of these chips, because we don't need any of these socketed chips to get the death chime, I'm pretty sure. And if I revert to my wiki, if I can find it, this is why I made it. So several chips can be held in reset. So we're not talking about the reset line, very minimal boot. So this is what we're after. No boot, no sound, blah, blah, blah. Then this is what we can do. The following ICs are critical. The UK8, so the 68K on here is, you can't really see that. 1 second, let's go to the overhead. Zoom out. Now we're done looking at the board. Oh, trust me, we've turned it off and on about 50 times just to, I do it off stream as well, in the hopes that this just starts working. But it just never does. So critical for boot, this chip, 68K, Glue Logic, which we've also swapped, I believe. You can correct me if I'm wrong, but I think in the last, I'm 99% sure in the last video we swapped this as well between a working one, so we know that's good, which was, yeah, we definitely did. The PAL UH7, so that is where's UH7? Oh, this one. So this is critical. UI6, so this one, so these two here, this, so these 4 chips here are critical. The pull-up resistor packs here are critical. Now, I've put that UE10 is critical. It is and it isn't. You can remove it and remove these two at the same time, and it will still boot, you just lose reset. But this is from the working board that we've just put it on, so we know that's good anyway, that's not a problem. The ROM, obviously, which is down here. This ROM, which we know is good and it was booting. And then I haven't finished off the critical ICs on the wiki because I know for a fact these are critical as well. But in terms of large ICs, that's what I've written down is critical. And what else can we do? Now boot from 5 volt. Remove the sound chip 2 if you want to, which we don't need to, so we can ignore that. Non-essentials. These are things I've proven. So if I put the, I don't know, you can see this over because it's quite a small overlay. I can probably zoom in a little bit so you can see maybe. The non-essential ICs are UD1, UK4, which is the real-time clock here, UD12, UE12, UG12, and UI12. And the way this board works with designations is you'll see, if you look at it for a little bit, you'll realise you've got 11 here, 11 here, 11 here. So if you go across the board, this is 11, you get high, this is 12, you get lower, this is 6. So going up is numbers, and going across is letters. So as you go across, you'll get H, I, J, K, L. So that's how you can kind of quickly see where you need to go. So we have a bunch of 11s, U, J, K, and L 11s. So there's the L. The K will be here based on this. So UK 11, UJ 11, and UB, UK 12. So basically it's saying the VIA is the swim chip, all that's non-critical. The FPU is not critical for booting. All the RAM isn't, and it's not in. The video IC UK 6, so yeah, that's not critical for boot. Everything on, which I'm surprised at, UI2, UJ2, UI3, so near the bottom of the board. Move this monitor further out of the way. I've actually, apparently I must have done it at some point. Done. Where's the 3s? Where is UJ, UI, UJ4, UI4, UJ6? It's all these, isn't it? So all these are non-critical, apparently. Now, I could have sworn they were. The resistor packs 1, 4, 5, 6, and 8. So I must have removed all these to get boot. So what I'm thinking is, this is one thing I wanted to do, but I also don't want to do in one way, and it's to take the working one and gut the board, like literally take everything off that's not preventing this making a sad Mac tone, because then you're really limiting yourself to what could be wrong, because this one's gone from, you know, working to just no tone. But in another sense, if we do all that and then find just a blob of solder somewhere, we're kind of going to be kicking ourselves that we've got to build it back up again. So what I'm thinking is, I don't know, I'm kind of hoping this just works, to be honest. I think that's where we have to go. I think we've got to kind of take a working board and break it so it doesn't work like this. Starting with socketed stuff, that's easy. So if we take, where's the fully working one? This one. I think what we've got to do is get this one on, and we know at the minute there's no RAM, and if we power up, is that in the right way? No. You get that, it's quite quiet, but you can hear that, I presume. Sometimes this is loud, other times it's really quiet. But yeah, that's basically making the tone. And what we want to do is remove things. So we can do that now. Let's just do some basics. What I'll do is just remove the socketed stuff. So let's just remove all the video circuit. It's all written on, so I know which ones are which. UI6, UG6. So I can go ahead and take all these chips off and see if we still get the sad Mac tone. And then we want to just basically continue this all the way to the point where the less that is on the board, the less that can get in the way. That's the idea. Because if something's faulty, and if one of these chips has decided to go faulty, it can be stopping sad Mac. As soon as we get to sad Mac, we can build a way back up. But we've literally got ultimately what was a fully working board being a completely dead board. So it's gone from one extreme to the other. So we really want to try and find somewhere that I'm losing my marbles, trying to plug it into the swim. So that, taking all them out, that stops audio. Or was it off? There we go. Yeah, so that stops audio. Yeah, the power connector's the same across all of them. We've had all these working at some point. Like, we've literally had this board fully working, it just died. So one of these is needed. I'm going to guess this one because it was on the critical IC list. So let's put him on. There we go. So this one is critical, they aren't. So let's now just remove, we'll keep them to one side. Remove those same chips from our board, and you get the idea. This is kind of, I guess, differential diagnosis in a way. We're just checking between a working board and trying to break it to the point where we have the least amount of components on this board possible. And then one thing to be careful of when I'm taking these video RAMs out is these are actually not in the full sockets because we didn't have them. So let me just stuff something in there so I don't damage the actual PCB taking these out. You'll see in a moment why. So those sockets are just sockets without a centerpiece. So if you go digging in, you can dig in. What people tend to do is they'll put the tweezers under here and pry up and the tweezers dig into the board. So that's why you ideally want the proper sockets in, but this is one of the packages we don't have. That's all fine under there, no damage. Let's take these out. These are the right package. And this one. That's still turned on. No. No change. So let's continue removing. There's a few more chips we can remove. So we can't remove him. We can remove this video ROM then, I'm pretty sure. And then we should still get audio. I need to order another one of these speakers, so I've got two. Yep, same noise, so I'm not sure whether you can hear it, but we still get the tone. So video ROM isn't crucial. There's nothing left socketed that we can remove, so unless video ROM is the key, we'd be down to removing components, which I'm not against doing, and like I say, that'll be one way we'll figure out what's going on here. But if we start doing that, I'm half tempted to just remake a reloaded PCB, because that's like a lot of work. Nope, no audio. And like I said, the other thing is we didn't check, to be honest. Oh no, I was going to say we didn't check for the audio. If the audio works, but the last time this was working, it did work, and we did scope the data pins. So it's one of them where I highly doubt the audio is the problem, but we are expecting the audio to make noise. We could be gutting this board and it'd start working. But I don't think that's the case. So let's just quickly probe on the scope to make sure we still don't have much data activity in case this started booting and we're that unlucky, which we could well be, that it's actually now trying to make sound and isn't. So let's just spin up the scope, chuck this on here and reset. And no, the same thing. So the data literally starts and stops. I mean, the other thing we could do as well is just probe around, like we did on the other chips. We could sit and probe all of the pins, but you're going to be here forever looking for a needle in a haystack. I think it's better to remove chips at this point, I think. It's just one of them. I'm going to love to find out what this ended up being to go from working to literally nothing at all, like no diagnostics. Because the other thing is, just missed that comment, sorry. Quick question, when will modded pre-builds GBA be done? Zach's away for a week, so probably we did everything before he went away, but there's a few left, so probably won't be this coming week, but it will be straight away. As soon as he's back, he's on them again, so you're probably talking about a 2-week wait for the Game Boys. Yeah, I've done TikToks on this. This has been in for about 3 months. Poor Josh has been after this for ages. I fully fixed it, it went back, had some other issues, come back, fully fixed it, and then it died when we were about to send it back. And then it's been here since. I've since brought 2 other Mac SEs, fixed both of them now, typically, and we still haven't fixed this one. So yeah, this is almost on the verge of the Megatech length of repair. But we'll get there, we'll figure it out. All I'm thinking is, like I say, you keep going back to the fact that it was working, and it can't be something complex because all I did was I was working up here and it stopped. But that really does hinder your repair and the way you approach repairs and the things you think. I'm just hoping that we don't do a ton of work and then find out we come all the way back up, and there's just something right here. Why is this one such a hassle? Basically because it's a complete dead system. So there's a few ways you can bring these up. One is listening for the SAD-MAC. When you plug this in, all you really need is a ROM and some very low-level critical things working, and you'll get a SAD-MAC tone, and then you can diagnose from there. We don't get any audio. The second option is you tap into this serial port here with a UART. I've even this is how far I went to try and fix this. I've written entire software to run diagnostics and run RAM tests, identify chips. I've literally written a huge piece of software to help with this diagnostics. So if I throw that up on screen, where are we? Over here. So, in fact, let's just pull it up on there. So this is the software I've written for it. If we run this, what you can do is connect up a UART to that port, and then you can run a load of tests, so things like identifying if the ROM works. So this would spin up, and then you'll have, obviously this isn't the right COM, but, oh, hang on, talking to myself, got it on the wrong screen. This is the software. So you select a COM port at the top, which is hidden by the sub thing that no one's subbed to yet, my little tips box up here. See this little tip box? We've got the COM here, you select. Then you can do all these tests, data bus, mod 3s, addresses, rev mods. You can check the ASICs, so you can put in ASCII mode and identify the machine. You can get responses, check ROMs, get RAM sizes, check the VIAs. All this I've written. It's all using some documentation that other people have open sourced on YouTube, but then I've made the software make it really nice, basically. So even this diagnostics tool, which is ultimately one of the first things we can do, is to solder onto here and check. The diagnostics doesn't even work. It literally does nothing. So it becomes a question of, right, this is ultimately almost a dead board, and you're looking at the critical stuff down here. But again, the problem is we've swapped this chip, so the critical glue chip, it's not that. The 68K is almost definitely working because the bus starts toggling and fails. These ROM chips are brand new, the sockets are brand new. These have all been changed. So you're really down to the point where whatever's gone wrong, it was working, and something that used to work is now wrong again, basically. That's the issue we have. And it's one of them where if this come in as a fresh repair, then what I'd probably be doing is swapping all these out, removing the FPU, swapping the ROM chips out, swapping the glue chip out. But because we've worked on it and because I know they're all good, that's what's holding me back from going, let's pretend this isn't the same board and starting again. But I think that's where we're going to have to go with this. I think we're just going to have to treat it as, let's pretend I've never worked on this board, stop using the bias of the previous history of this board, kind of making me to go a certain route, and let's just say, right, it's a brand new board, doesn't work, we're not getting anything, this is where I want to look, I want to change all these. But the other side of it is as well, we should probably take this working board and break it down as much as possible, remove as many of these chips as we can, remove as many of these, literally start gutting this board. I'm going to have to build it all the way back up again after, that was the only thing, but it's not the end of the world. And getting it so we can remove as many chips as we can and still get that audio coming out. And then once we've done that, say we strip this board down and we find the bare minimum amount of components on this board we need to make the sound. We then go to this board, without whacking the camera, and we remove all those other chips. And then we start to put the other chips back on, swapped off the working board. So it's basically just a long, boring process. It's almost like we need to stream it on a weekend, put some music on, and just work away, because it's not that technically involved and it's not that interesting mentally to, keep me stimulated to want to do that. But I think that's the goal. We'll learn stuff along the way. We'll learn literally what's the minimum we need on this board that nobody else seems to know. Like, if you ask, right, what can you take off this board to just get the sad Mac tone? Nobody knows. No one's taken it that far. So that's what we're going to learn from doing it. We're going to gain some knowledge and we're going to share it. But it's just a bit boring, basically. It's just something I'm not overly interested in doing. So I think it's got one of them. We sit on a live stream. You guys keep me entertained while I sit and remove chips. And I think that's how we solve this one. We've checked everything we can visually. We've looked at the bottom of that board everywhere. So all that, we've looked at everything. There's no missing chips. There's no shorts. It's a brand new board, so I highly doubt we're dealing with trace damage. The top of the board we've looked at looks fine. I've already worked on this and reflowed nearly everything, so we really are down to, I think, a component's failed. Personally, that's literally what I think must have happened. Or is it going to be as simple as this? Like, is it these ROM chips? But these are a nightmare to remove, and I'm probably going to break them removing them. So I kind of don't want to remove them and put some more in. I've got more spare, but they've only just gone in and they're new. But that would technically be a fairly simple job. But I don't think so. And we removed this ROM socket because it was dodgy. And we put these in for that reason, but now the problem is we can't swap the ROM chip over easily because we've obviously removed it and put these in the way. So, yeah, I think that's where we're at. So I'll probably jump on a few other jobs in between this because I think that's the next step of this. It's a long process of removing chips. But every time I work on this, I'll probably just jump on a live, maybe do it in sections, just do one live where we remove all the components off this board until we lose the chime, and then probably have a break at that point to come back on and start putting them onto this board. So it'll probably be a few streams yet until we get this one working, unfortunately. Unless the dishwasher overnight fixes this. I think that's, I'm going to hold out hope for that as well. So hopefully this is worked for everybody now. I think we've figured out the problem with the stream on Twitch. It's that I can't stream any higher than 6 megabits, but it does seem to be working and the quality's still fine. I haven't gone live on Kick because it's just full of bots at the minute, so until we get chat moderation on, that's going to be a nightmare. But I think Facebook's working, YouTube's working, Twitch is working, TikTok's working. TikTok, I've completely forgotten to ignore all the chat because it doesn't pull in. So apologies if you're on TikTok and I'm not even talking to you because I forgot to even open that up when it went live. And I presume I'm live on TikTok, I can't remember. Let me just double check. But, oh yeah, I think we checked, didn't we? And we're going to get a sound echo now if I go live. Yeah, so I'm on TikTok as well, but I forgot to keep the chat open for that. I could do with a way to... actually, saying that, no, we're not. I think TikTok chat pulls into the multi-stream, so I think I would see people messaging on TikTok, but you wouldn't see them in the stream. It'd just be I'd be talking to myself because they pop up. So yeah, I think that's it. I'll leave it there for now, and then you'll see me again probably tomorrow or Tuesday.